Welcome back to Java Internals Crashcasts. I'm Sheila, and today we're wrapping up our season on the fundamentals of concurrency. We've covered a lot of ground, and I'm excited to tie it all together with my co-host, Victor. Before we dive in, let's start with a quiz question for our listeners. Victor, would you like to do the honors?
Absolutely, Sheila. Here's a brain teaser for our listeners. In a busy restaurant kitchen, multiple chefs are preparing different dishes simultaneously. Which Java concurrency concept would best represent the head chef who assigns tasks to the other chefs and manages the overall workflow? Think about that as we recap our season.
Ooh, that's a great question, Victor. It really makes you think about how concurrency concepts apply to real-world scenarios. I'm sure our listeners will be pondering that as we go along. So let's start with a brief overview of what we've covered in our Fundamentals of Concurrency season.
Excellent idea, Sheila. We began this season by introducing the java.util.concurrent package, which is the cornerstone of Java's concurrency utilities. We then explored Executors and Thread Pools, moved on to Futures and Callables, covered Thread Basics, and finally delved into Synchronization Fundamentals.
That's right, Victor. It's been quite a journey. Let's start with the java.util.concurrent package. Can you remind our listeners why this package is so important?
Certainly. The java.util.concurrent package was introduced to address common concurrency problems and provide higher-level abstractions for developers. It offers a set of powerful tools that make writing concurrent code easier and less error-prone. Think of it as a well-equipped toolbox for handling multiple tasks simultaneously in Java.
I like that toolbox analogy, Victor. So, if java.util.concurrent is our toolbox, would you say that executors and thread pools are some of the most frequently used tools inside?
Absolutely, Sheila. Executors and thread pools are like the power tools of concurrency. They allow developers to manage and reuse threads efficiently. Instead of creating new threads for every task, which can be resource-intensive, thread pools maintain a set of reusable worker threads. This is similar to how a restaurant might have a team of waitstaff ready to serve customers, rather than hiring a new waiter for each table.
That makes a lot of sense. And if I remember correctly, we talked about different types of executor services, like thread pool executor and scheduled executor service. These give developers flexibility in how they manage concurrent tasks, right?
Exactly. Thread pool executor is great for general-purpose thread pooling, while scheduled executor service is perfect for tasks that need to run periodically or with a delay. It's like having both a general kitchen staff and a specialized pastry chef in our restaurant analogy.
Moving on to our next topic, futures and callables seemed a bit more abstract at first. Can you break them down for our listeners, Victor?
Of course. Futures and callables are all about handling tasks that produce results. A callable is like a task that returns a value, while a future represents the promise of that result. Imagine ordering a complex dish at a restaurant. The callable is the chef preparing the dish, and the future is the waiter's assurance that your meal will be ready soon. You can check if it's done, wait for it, or even cancel it if you change your mind.
That's a great explanation, Victor. And we also covered completable future, which takes this concept even further, right?
Absolutely. Completable future is like a more advanced ordering system. It allows you to chain operations, combine results from multiple tasks, and handle exceptions more elegantly. It's perfect for complex workflows where one task depends on the results of others.
Now let's talk about thread basics. This chapter felt like we were getting down to the nuts and bolts of concurrency. What were the key takeaways here?
Thread Basics is indeed foundational, Sheila. We learned about creating and starting threads, their life cycle, and how thread priorities and scheduling work. Understanding threads is crucial because they're the fundamental units of concurrent execution in Java. It's like knowing how individual chefs work before trying to manage an entire kitchen.
That makes sense. And finally, we covered synchronization fundamentals. This seemed like a critical topic for avoiding problems in concurrent programming. Can you elaborate on why synchronization is so important?
Absolutely, Sheila. Synchronization is all about coordinating access to shared resources to prevent data corruption and ensure thread safety. We explored the synchronized keyword, object locks, and wait notify mechanisms. These tools help prevent scenarios like two chefs accidentally using the same ingredients simultaneously or trying to use the same cooking station at the same time. Proper synchronization keeps everything running smoothly and prevents conflicts.
Thank you, Victor. That's a great summary of our season. Now, before we wrap up, let's reveal the answer to our quiz question. In the busy restaurant kitchen scenario, which concurrency concept best represents the head chef managing tasks and workflow?
Great question, Sheila. The head chef in this scenario would best be represented by an executor service, specifically something like a thread pool executor. The head chef executor service assigns tasks to other chefs, threads in the pool, manages the overall workflow, and ensures efficient utilization of resources. Just as a head chef coordinates the kitchen's activities, an executor service manages and executes concurrent tasks in a Java application.
Excellent explanation, Victor. I hope our listeners found that analogy helpful. As we conclude this season on Fundamentals of Concurrency, I want to emphasize how these concepts work together to create powerful, efficient, and robust concurrent applications. From the high-level abstractions in java.util.concurrent to the low-level details of thread management and synchronization, each topic we've covered plays a crucial role in modern Java development.
Absolutely, Sheila. Understanding these fundamentals is essential for any Java developer working on applications that need to handle multiple tasks simultaneously or make efficient use of multi-core processors. And remember, concurrency is a deep topic. There's always more to learn.
You're right, Victor. And speaking of more to learn, in our next season, we'll be diving into synchronization utilities, where we'll explore more advanced tools for managing concurrent operations. We'll cover topics like locks and conditions, synchronizers, atomic variables, and advanced synchronization techniques.
I'm looking forward to it, Sheila. It's going to be an exciting journey into even more powerful concurrency tools.
Absolutely. And to our listeners, thank you for joining us for this season of Java Internals Crashcasts. If you've enjoyed our deep dive into Java concurrency, please subscribe to our podcast and leave us a rating. Your support helps us continue creating in-depth, educational content. Until next time, happy coding.